Now, before cutting the last video, which was too long, I wanted us to focus on graphs and calculation individual, okay? So the graphs won't take too long. So let's have the graphs, okay? Let me say graphs. Graphs, on graphs, what's going to happen on graphs? Okay, on graphs, assume that you are having, let me try to fix this, a graph that's like this, okay? Yo, why is it? Okay, yebo. So this is my graph. Let's have a graph of this some sort. So this is, let's say this is 1 minute and two, or rather seconds. Okay, let me say this is time in second. Time in seconds. This can be voltage, or let me say EMF in voltage, or just voltage. Okay. So this here, it is my maximum velocity. It is 100. So not maximum velocity, it's maximum voltage. This is negative 100. Okay. So now, what is it that I can do to increase the voltage? Okay. So if I want to increase the voltage, okay, what can I do? The first thing that I can do, it is to what? Remember, according to this formula, EMF is equal to negative N change in magnetic flux divided by change in time. If now I decrease my speed, my time, okay, I increase my EMF. But now, how can I decrease my time? If something is happening faster, it means my time is short. Okay, so it means I can increase my what? Increase. Let me say double the speed. Okay, let me say increase the speed. Okay, whether I can double it, triple it, or whatever it. Okay. The second one, what is it I can do? Remember now, the magnetic flux here, the magnetic flux here are generated by the what? By the magnetic field. Okay, magnetic flux from the magnetic field. And the magnetic field, I get them from the what? From the magnet. So if I were to use a strong magnet, if I were to use a strong magnet, so then I would have what? A greater voltage like that. Okay. So now, if I increase the speed, if this one is 1 minute here, so 1 second, and this is 2 seconds. If I double, let me say I double my speed, which is the same as when I double my speed. Remember, speed and time are inverse proportional. When I'm doubling my speed, is the same as halving the time. Okay. Remember, if it is double, when I do the inverse, it is half. If I triple the inverse, it is 1/3. Okay. So now, if I double my speed, it means my current is going to move from 0 to now a new value of 120, so of 200 and negative 200. But now my time will now be reduced to what? To 0.5. 1 will be 0.5 and 2 will be 1. So it means now, instead of returning back to 1, it will now go up and return to half time, which is 0.5, and go back down there and return back to a new full cycle, which is 1. Can you see that? So this is what is happening when I increase the speed or use a strong magnet. Okay. But now, what if now I decrease? Okay, let me return that. What if now I'm decreasing? Let's say now, let me use a color, different color. What if I am decreasing the speed? Let's say I am halving the speed. Remember, if I halve the speed, it's going to be half, okay? So now time need to be in the inverse. What is the inverse of half? It is double. So it means when I'm halving the speed, it is the same as doubling time. Doubling time. Okay. Here I said I am doing what? I'm doubling the speed. Remember, double is 2 divided by 1, which is 2. When I take the inverse of this, it is the same as half. Can you agree with me? Yes. So now I'm doubling my time. So if I'm doubling my time, it means this one, I was going from 0 to 1, okay, but now instead I'm gonna go from 0 to 2. I'm doubling my time, okay, and then return back and complete my cycle at 4. At 4, like okay, but what is gonna happen is, let me do this. Let me try to extend this and say this is 4. When I reduce my speed, also my voltage is being reduced. So it means my voltage will now be 50, half. Okay. When I reduce my speed, I also reduce my voltage. Okay, by whatever fact. So I'm halving my time. Okay, I am saying I'm halving my time. Okay, there is no halving like this. Halving my speed. So it means it's gonna be 0 and 2, then 2, 2, 4. Can you see now? My speed was reduced. Therefore, if I reduce the speed, I'm increasing my time. Therefore, my EMF will be decreased. Okay. So this is what you need to know. Okay. We'll look more into this when we look the question papers. Okay. Yes. And also calculations that you need to know is that I maximum. Remember when I want to reduce. Okay. Let me say IRMS. IRMS is what we need, okay? So I need to convert from IRMS to from IMAX, the one that we get from the supply. Okay? I need to convert it to IRMS, so I need to divide by square root of 2. Similarly, VRMS, the one that we have from the kettle and all of that, it is Vmax divided by square root of 2. Okay, you also need to use the power formulas. P average is equal to VRMS. Every time when I'm using power formulas, I'm going to use IRMS, RMS, all RMS, okay? Or I can say P average is equal to V squared RMS divided by R, okay? Or P average is equal to I squared RMS multiplied by R. Remember, these are formulas that we take from electricity, but now since when we are using, we are dealing with machines here, generators and motors, we need to indicate these are RMS, okay? We can also use energy formulas, okay? Energy formulas goes like W is equal to VRMS. Oh, on energy formulas, yeah, we also use this one. W is equal to VI changing time, okay? Also, what's this other one? W is equal to V squared divided by R multiplied by changing time and all of that. But do not forget to indicate the voltage that you are dealing with here. Is it the RMS or the maximum? Okay, but yes, you will be given these formulas on your answer sheet. So not answer sheet, formula sheet. So please use them. Okay. So please use them. Okay. So thank you very much, folks. That's all I had for you this today. I hope you enjoyed the video and also the previous one. So thank you very much. Thank you, folks. Until you meet on the next video, where we'll be now doing question papers. Okay. Yes.